Hello, everyone. I'm Stephanie Boozer with Cugc HQ, and so happy to welcome you to today's user share all about Terraform. It's going to be a big introduction. I think we are going to hear about what it is, what it can do for you, and then also hopefully some demo stuff and how some tips and tricks, for you to use it in your own environments. Alrighty, so before we get started, just want to remind you of some upcoming Cugc events. Tomorrow, of course, is our Excel event in Louisville. If you're in this webinar, you may or may not be able to get to Louisville tomorrow, or maybe you're in Louisville, but either way, it's going to be a great day. And then we've got just some more webinars and local group meetings coming up. You can scan that QR code. It'll take you straight to our events calendar, and you can find all of these events and get the registration information, the agendas, all of that good stuff. Alrighty, so we are recording today's presentation, so you'll get a link to that recording tomorrow. It's going to come to you from GoToWebinar, so be on the lookout for that. Also, we'd like you to submit your questions at any time. We're going to take as many as we can throughout the session today. So just type them in as you have them, and we'll get to as many of them as we can. All right, so let me introduce who we have with us today. Our presenter is Jake Walsh. He is a Cloud Solutions Architect with CDW UK. Jake is often in webinars with me as a moderator, but today he's a presenter. So happy to have you on in a different role today, Jake.
Yeah, great to be here. Yeah, thanks, Stephanie. Looking forward to this one.
And then looking at all your questions and helping with the discussion is Esther Barthel. She's a solutions architect with Cognition IT. She is one of our founding members of the Cugc Women in Tech group, and happy to have her on today. Hi, Esther, welcome.
Thanks. I'm looking forward to all the questions and making sure that I give Jake an opportunity to answer them.
All right, well, I'm gonna hand things right over to Jake. I'm gonna send you the screen right now. There you go.
Thank you. Right, I will just, hopefully I've remembered how GoToWebinar works. Just checking you can see a PowerPoint screen now.
Yes.
Yes.
Awesome. Cool. Okay, yeah, we'll make a start then. I just want to start really with some goals and an overview of what we're going to cover in this session. Just kind of give some background and talk you through the kind of the purpose really. So the purpose of this session really is to give everybody attending a basic introduction to Terraform. You know, Terraform, I'll be honest with you, is a complex product. It's something that does take a little bit of time to learn. Once you learn it, it is awesome. Been on that journey myself for a while now, and I can say that you know, very truthfully, it's very, very powerful. But I think it's something that, you know, just starting on the right foot is important. So I'll sort of cover off the getting started. You know, how do you actually get started? I've got some useful tips and tricks. You know, things like getting it installed easily. You know, what you need to support it. You know, things you can use for learning. I've got some resources I'll share at the end. I'm going to cover off as well some of the use cases for the Citrix administrator. So, you know, obviously conscious this is a Cugc webinar, you know, so there's a very important link there. So I'll cover off some of that as well. I think, you know, one of the things that this session will aim to do is kind of, you know, teach you to walk. And you will learn to run yourselves. You know, it's not sort of going to make you a superstar overnight, but it will give you the grounding you need to understand a bit about Terraform. You know, understand how you'll use it, what it is. You know, and I've been praying to the demo gods for the last couple of days, so I'm going to try a live demo. I'm sure I probably cursed it by saying that, but hopefully I'll give you just an idea of how powerful it is and some of the basic use cases as well. So yeah, feel free to put your questions in the chat. You know, quite happy to answer as many as we can, and yeah, hope you find this useful. So we'll start right at the top. What is Terraform? So Terraform is actually an infrastructure as code software tool. Can interact with a wide range of platforms and environments using something called a provider. I'll cover off what a provider is shortly. Typically found in 3 varieties, so open source, which is the variety of Terraform I'll be using today. There is also a cloud offering that HashiCorp will provide and host for you, and there's also an enterprise version of Terraform where you can host it yourself. The angle I'm coming from, most of my experience with Terraform is actually across Azure, AWS, and using Citrix ADC. For my demo today, what I'm going to actually do is just demonstrate the build out of some resources in Azure, make some changes, update them, and just kind of show you that as an angle. So I think, you know, once we think about what Terraform is, it's important just to understand what infrastructure as code is, because, you know, that's the reason we're using Terraform. So it's a method of managing and provisioning infrastructure resources via code. So think of things like, you know, networks in Azure, you know, resources like virtual machines, disks, you know, all of those sorts of things provisioned via code files. Usually it's a JSON file with imperative or declarative code. What do I mean by that? So imperative is kind of me saying, I would like you to do X, Y, and Z in that order. You know, that might be a PowerShell script to create an Azure resource group, create a VNet, and create a subnet in it, and we'll go through that in that order. Whereas declarative, and that's the type of infrastructure as code template that Terraform is, will describe the end result. So it will say, this is a piece of infrastructure deployment that has 2 resource groups in it. It has a virtual network, 1 in each resource group. It has subnets. These are the IP ranges of those subnets. So for me, what I typically find is that makes it much, much easier to read. You know, let's be honest, if we all sat down and had 500 lines of PowerShell, you know, we could sit there and work out what it was deploying, but it might take us a while. With a declarative code template, I actually find myself, you know, I can sit down and look at it and have a pretty good idea of what it's deploying. I certainly find it a lot easier to work with and use. Terraform in particular, you know, is often integrated into version control systems, you know, so Git. You know, myself, I deploy my own lab environments using Azure DevOps. You know, I've done customer work using Azure DevOps, GitHub, all of those sorts of things. It's also edited, you know, with a lot of common tools. You know, so for example, today I'll be using Visual Studio Code. I have a plugin installed that makes the Terraform, you know, highlights the various syntaxes and just makes it a little bit easier to read, which certainly makes it very useful as well. So you don't need anything special. You know, you don't need to go and purchase a, you know, top spec laptop. You don't need to go and, you know, pay for an expensive piece of editing software or anything like that. Everything I'm going to show you today, obviously, other than the cloud provider platform being Azure in this case, you know, you can do for free and very easily using open source or freely available products. I think it's also important to note for infrastructure as code that it's usually adopted as part of a wider DevOps strategy. Now, I do want to caveat that slightly, that I actually use Terraform all the time in my day job as a cloud solutions architect, predominantly for demo purposes, actually. You know, on numerous occasions, I'm asked by customers, please, can we see a demo of this, you know, something like Azure Virtual Desktop? Can we have a demo of, you know, some VPCs in AWS, something like that? And I have Terraform environments that build those out for me. So, you know, if I deploy them using something like GitHub or Azure DevOps, I can be sat on a train, I can trigger that deployment, and then I can go to the customer and do my demo and then destroy it at the end of it. So not always as part of the DevOps strategy, but often from an organizational level, if you choose to adopt Terraform, it's usually part of that type of strategy. This, I think, is probably one of the most important slides as well. You know, I've talked about what infrastructure as code is, but I want to talk about the why. I think something that's really important about this, you know, is this is a cycle, and these things within this cycle all have an impact on each other, and it's sort of a snowball effect. So, you know, think of if you create a template that builds out a specific piece of infrastructure for your company and you need to deploy it in 10 locations globally. Well, that's great because you only need to write it once. You write it once, it's repeatable. Oh, that means we can deploy even quicker. Oh, and because we can deploy quicker from a known good template, the risk is minimized. Oh, and it makes us more consistent. You can see the pattern developing here. Far more reliable than clicking through the portal. You know, we're all human, we make mistakes. You know, when I use the Azure portal, if I did the same thing 10 times, you know, on a good day, we might get 7 of them the same, you know, the other 3, maybe some variation. You know, it's always a challenge when you're doing things, you know, manually, mistakes will get made. The opportunity to write once and deploy many times is also a massive selling point. You know, if you you know, work for a provider or a company that builds infrastructures for customers, or you have a particular product that you go and implement into customers' environment. If you have code that has been written well, it's been tested, you can go and deploy that without the worry of having to go through that process every time. Think about that from the perspective of something like an IT service provider. If you have a standard deployment into customers for your jump box or your security software or something like that, once that code's written and tested, you can get that deployed in a repeatable, very reliable fashion. The other aspect that's really, really important is the ability to duplicate environments quickly. So this comes up a lot when I talk to customers who, are sort of on the larger side, perhaps, where they have a pre-prod environment, a dev environment, they do isolated testing of some of their applications. It's perfectly possible with Terraform to take, let's say, a deployment of infrastructure in a cloud platform, Azure, AWS, GCP, something like that, and then actually have multiple versions of that just by changing some of the variables. So, for example, let's say you were a customer, you were building out your production environment in Azure, and one day you decided, actually, we need to have a development environment. Or rather than manually looking at that, building it, getting it to sort of mirror production, you could just duplicate the code or change some of the variables to point at a different subscription, redeploy the environment, and off you go. You have something you can test against. One of the things that I think is really I haven't put it on this slide because these are kind of the core reasons, but something else that's really important for me is infrastructure as code allows you to make infrastructure on a temporary basis. And what I mean by that is just going back to that lab example and the demo example that I used earlier. Sometimes it's not uncommon for me, in my job particularly, to have something running for 2 hours, 3 hours maximum, where I need an environment, I need it built quickly, I need to show a concept to a customer or prove something meets their business requirements with a demo, and then I need to destroy it. Very, very cost effective. I can build out Azure environments based on a template that, if I left it running for a month, would be a couple of £1,000, whereas with Terraform and a well-written template, I can deploy it, have 2 hours of running of it, it costs £5 to £6, and then I can destroy it afterwards. So that's another massive selling point for the product. So let's talk about how Terraform works. So the code is typically arranged across a number of files, I'm sure you'll all fall off your chairs in shock. They are known as TF files because they have the extension TF, which obviously stands for Terraform. These files define the infrastructure and the configuration that we want Terraform to apply. So there's an important point here, and this has come up, in discussions I've had with colleagues recently, where there's sort of two schools of thought you can have. One is, do I put everything in one TF file and deploy it? And the other is, do I split it across, this one's for networking, this one's for, virtual machines, this one's for, storage accounts or S3 or something like that. Truth be told, there's no difference. As long as it works for you, you can easily understand the files and you can work your way around them. It doesn't matter. My advice would be view it as a human being. What makes it easy for you to work with Terraform? That's what's going to keep you sane. It's what's going to make it easy to find what you need to find and just keep things in a manner you can understand. So for my demo, I've got everything in one file because it's quite a small demo. So just a single TF file describing my infrastructure, but I just don't want you to go away thinking, everything has to be in one particular file. At the time of actually running Terraform, what then happens is all of the TF files in the folder we're running Terraform on actually get analyzed. They all get put together, analyzed. Terraform looks at them and it builds out what's known as an execution plan to apply those changes. So if you've got one file that builds 10 resources, it will analyze that file and make a plan to build those 10 resources. Likewise, if you've got 10 files each with one resource in, it will build a plan that involves building 10 resources. It will analyze all of those files and work out how best to build that for you. Now, this is another really important point. Terraform will actually work out the dependencies for you. So for example, and I will show you this in my demo in a little while, let's say you're building out 2 virtual networks and 2 subnets in a single Azure resource group? Well, if you're familiar with Azure, you will know that subnets sit within VNets and VNets sit within a resource group. So what Terraform actually does is it works out those dependencies for you. It knows that it can't go ahead and create the subnet straight away. It needs to do the resource group, then it needs to do a VNet, and then it needs to do a subnet. So that's one of the really powerful things that Terraform can do for you, obviously by using one of the providers, and I'll show you those providers in a second. So yeah, once we've done that, we have the execution plan, we can apply our changes, and then we'll actually see that reflected in something like the Azure portal, you know, or the AWS console, or whatever it may be that we're applying Terraform against. So just a note on authentication and providers. This is really important. So before we can actually run any Terraform, we actually need to add a provider. Now, we could run Terraform without a provider, but it wouldn't be able to interact with these external APIs. So think, you know, something like the Azure platform, something like AWS, something like GCP. We would need to add a provider so that Terraform could interact with that platform. In simple terms, providers enable communication with platforms or services outside of Terraform. So my example is going to be based on Microsoft Azure. We'd need to add the Azure RM provider to Terraform before we can interact with Azure. Bear with me 2 seconds. I'm going to hopefully demonstrate my highly advanced GoToWebinar skills now and switch to a different application and just show you these providers. Oops. Okay, hopefully you are seeing a Google Chrome window. It'd be awkward if I was just sharing a desktop background and talking for, for 5 minutes. So this is just an example of the providers, and obviously if you go to the registry.terraform.io, you'll see, you know, all of the major platforms you know, have a provider you can use. We're obviously interested for today's demo in the Azure provider, but there's other ones for AWS, Google Cloud, Kubernetes, you know, Alibaba, and there's a whole host of other providers that allow you to build functionality in. So for example, if you want to interact with Azure Stack, you want to do, you know, interactions or look up DNS, those sorts of things. You want to do interaction perhaps with an on-premises AD or Azure AD. There's lots of different providers you can add to Terraform. I would liken these in a similar fashion to how, you know, you might add a plugin to a piece of software, or you might add, you know, a browser plugin that does an extra function for you. Providers add functionality and communication to external platforms to Terraform. I'll just show you the ones we're going to use today. So obviously the Azure provider, pretty important if we're going to interact with Azure. All of these providers, and this is one of the things I really like about Terraform, the documentation is fantastic. It really is awesome. So if you know that you want to work with Azure, you would go to the providers page and you would click on Azure, and it would take you to a page like this. Just click on the documentation tab. If you want to then use that provider, you simply press use provider, copy this code and paste it into your Terraform configuration. And that just tells Terraform, hey, I'd like to use the Azure RM provider provided by HashiCorp. This is the version I'd like to use, and these are any configuration options. So very, very easy. It's the same, you know, if you want to use this as the random provider, again, you just press this and you would just need to take the block and add it to your code. Makes it really, really easy. The other thing that's really good about the providers, particularly when HashiCorp, you know, when they're referenced in this registry here by HashiCorp, the documentation for all of the resources, every single one of these comes with an example. So I'm just going to find a useful example to show you. Let me just go to resource group if I can find it. Just do a quick search. So again, you know, you can just do a quick search here for whatever you need. So I'm just going to have a look. Here we are, Azure RM resource group. So straight away, I can find the resource I need. And if you scroll down here, you'll notice every single type of resource you could want comes with an example. What's really useful as well is these are all workable examples. So you don't have to sort of go away and work out what's been done. You could take this, copy it into your code and deploy it as is. So it makes it very, very good for learning or, you know, trying to build out things and understand stuff. A resource group example is obviously, you know, you're probably thinking, well, that's great, but it's really simple. So let me just show you another example. Let's say I want to create a Windows virtual machine. So here in Compute, Azure RM Windows virtual machine. What you'll notice here as well is this particular provider doesn't just show me the Windows virtual machine. And again, this is another reason why I think the documentation is so good and so relevant for learning. this is a fully workable example of a virtual machine with all of the resources it needs to be deployed. So again, you've got the resource group, you've got the network the VM will sit in, you've got the subnet that the VM will sit in, you've got the network interface, and then finally, you've got the virtual machine. So again, if you're looking to actually start learning Terraform and build some things, starting here is a really good place to start because it gives you, actual workable code examples that you can bring in and then tweak as you need.
This might be a great moment to at least address one of the questions that I saw in the chat. Jake, does Terraform take into account any dependencies that might occur between the different resources? One of the questions that was asked was, for instance, if I use Terraform to create a virtual machine, but also want that machine to be Azure AD joined, but I'm also using Terraform to create my Azure AD, how will Terraform know that it needs to create the Azure AD first and then wait until it creates the virtual machine? Do you know how it handles that?
That's a really good question. So there's kind of two ways dependencies work. One is dependencies where it's known by Terraform. So for example, if you try and build a virtual machine, it knows that it needs to have a resource group. And if I just show you, I'll give you an example down here. When we actually build the resource of the virtual machine, you'll notice it asks for the resource group. So that's kind of a clear dependency. If we have a dependency, for example, where we're building a resource, let's say we're building out some network resources, but we need them all to be built prior to doing something else. A good example of that I've used previously is I've generated random passwords using the random provider, and then I've used those passwords in place of, obviously, passwords like this. The problem with that is Terraform doesn't know that we need to generate the password before the VM's built. That's just a basic example, but we can actually then use a flag within the resource called depends_on, and we can say don't build this resource until the other resource is built. Now depends on should be used sparingly, otherwise you're going to have long chains of resources that depend on each other, but it's just something you can put in there. So if A relies on B, then we put a depends on A to say don't build me until B is done. That just means you've got that kind of that control over what's done and in the order it's done.
So most of the dependencies are already built into the provider that has that intelligence, but if you need to make it explicit, there's the depends on flag to make it very implicit. That
exactly that. Yep.
Perfect.
Thanks for answering that one. No, it's a great question. I shall now seamlessly switch back to PowerPoint. Cool. Hopefully you can see a PowerPoint screen.
Yeah.
Excellent. So key stages, this is another important point, and these are the key stages that I'm actually going to use within my demo. There are a few additional ones, but in the purposes of just providing an introduction and making things straightforward, these are the key stages I'm going to cover. So when we actually start with the directory that contains Terraform files, we need to run Initialize. What Initialize does is it initializes the binary, so downloads the required providers. So in the case of my demo, it will download the random and the Azure RM provider, and essentially sets up Terraform in that folder ready for me to use it. Terraform plan actually examines our Terraform files, and what it does at that point is looks to see what it needs to do to execute what we've asked based on our Terraform files. So the output of that is actually something known as an execution plan. And what I'll do when we get to the demo is I'll show you that, and then I'm going to do some rather horrendous changes to my Terraform just to show you how that plan output will change over time. The next stage would be an apply. So this is actually where we'd be asking Terraform, happy with the config, please go ahead and apply it. Interesting point to note that apply also runs plan. So I often use plan when I'm building code. I don't necessarily want to apply it. I just periodically run plan to check that the changes are as expected, and then I'll perhaps apply at certain intervals or something like that. Again, when you get the output of an apply command, it will actually ask you to confirm it. It won't just go ahead. It will give you a plan. You can check that plan is as you expect, and then you'll be asked to confirm that it, that you do want that to go ahead. Finally, would be the destroy. So obviously, yeah, use wisely. Does the complete opposite of apply. If you've got an apply that goes and builds a very nice, huge infrastructure, and you then run destroy, just as easily as you built that infrastructure, Terraform will take it away. So certainly something to be used wisely and carefully, but certainly has its place in those sort of key stages. So I just want to touch on the importance of the state file as well, because you can't really talk about Terraform without talking about state files. So Terraform needs to store information about your infrastructure, and it does that within a file known as the state file. When we actually do the demo in a little while, you'll actually see a state file gets created within the folder I'm working in. And that effectively allows Terraform to work out the changes it needs. So the state file is Terraform's current knowledge of the infrastructure deployed. And it will look at your code. It will go, well, this resource group exists in the code, but it doesn't exist in state. So I need to create a resource group as an example. That state file can be stored locally or remotely, depending on the deployment type. And slightly more on that in a couple of slides time. But for today, we're going to work with local state. So just in a single folder on my machine. That's very appropriate for testing, labs, development, sort of learning, all of those sorts of things. A remote state file would be far more appropriate for perhaps a team using DevOps tooling or, collaborating on code or something similar. So this is effectively how my local example will run. All of the work is going to be done on a single machine. I've written some code, I've got it saved into a local folder. Terraform will compare this to a state file, and then the infrastructure will be created, updated or destroyed, depending on which of those key stages, what task I've actually given Terraform at that point. This is really good when you're learning Terraform because it keeps things really simple, really straightforward. There's no sort of, integrating it to DevOps solutions or worrying about remote storage or anything like that. It allows you to just focus on the code. The problem with this is, let's say this is me. I'm sat there, I'm doing some work for a customer. It's great. The customer's really happy. I'm really happy because I'm just doing Terraform all day. It's kind of it's a perfect world, but then something happens. It's Monday evening, and I wake up in the morning and I've won the lottery. Oh, this is nice. So that morning I don't open my work laptop. I get on a plane. I'm sat on a beach drinking a cocktail, and my boss is frantically ringing me saying, the customer's asking, what are you doing with their work? Okay, slightly extreme example, and hopefully I wouldn't do that. I'd email it to a colleague at the very least or something like that. But it just demonstrates, working locally like this, saving and running the code locally probably isn't the most appropriate for, production in a business system or deployment for a customer or something like that. That's where a solution like this would come in. So where people would actually work on their own device using something like VS Code, and then once they'd written that code, they would commit it to something like GitHub or Azure DevOps as two examples. There obviously are other platforms you could be using. You then actually have Terraform running in a pipeline for you, so that could be something like GitHub Actions, pipelines in Azure DevOps. You could use something like Jenkins, Octopus. There's just loads of different platforms out there you could use. In the case of Azure, you probably store that state file in Azure storage, and obviously, this abstracts the running of Terraform and the storage of code away from that local device. So, if one of these people writing the code here suddenly decides, hooray, I've won the lottery, I'm off, see you later, we're not left in trouble, essentially. What this also means is if we are a global team, we've got people on different sides of the world, all working together, we're not reliant on one person. Imagine a scenario where at the end of the day, you had to email someone your code and then they ran it and came back and said, well, this line didn't work, that line threw an error. And, what were you thinking with line 46? It just wouldn't work. But having a solution like this, where you can actually collaborate in real time, commit the code to a central location, this is where, those kind of more enterprise deployments of Terraform really do come in. So a quick note on getting started. I will share a link to this script as well, and I guess a bit of a shout out. I use Cugc to install Terraform because I'm really lazy and I don't like to install things manually. I like scripts that do the hard work for me. So, if you do want to just have Terraform installed on your machine, I'd recommend using something like this. It will install VS Code, it will install Terraform, and it will install the Azure CLI, which are the three things I need for the demo today. So, as I say, I will share a link to that just at the end. But yeah, it just makes life really easy. You can run this on any machines you're working on, and just know that you've got the tooling that you need to get started. Cool. So it's time to see if all my prayers to the demo gods have been answered. Right, bear with me 2 seconds. We're just coming back to a browser window now. So I'm logged in here to the Azure portal, which hopefully you can see. Just in one of my subscriptions, I have nothing other than 2 network watchers in this subscription. So I'll just refresh that. Yeah, I don't want you to think I'm not doing this live. But yeah, there's nothing in this subscription other than the network watchers. So I've got effectively a blank subscription ready to deploy some infrastructure into. So what I'll do now is I'll just switch across to VS Code. Hopefully that VS Code window is showing up for you there.
Yes, it is, Jake.
Awesome. So just a quick kind of run through the files I've got here. So really there's 4 files we're interested in. The first is this provider.tf, and this has quite literally got in it a copy of that provider information I showed in the documentation site. So I've added 2 providers here. One of them is the Azure RM provider, and the other one is the random provider. I'm actually using random because as part of this lab, I'm generating some passwords automatically. I use this lab, in fact, as a copy of one of my demo environments. I use it just to quickly build out a small Azure infrastructure with a VM that can be promoted to a domain controller, and it just functions as something, I can spin this up in 10 minutes if I just need a small environment. So that's the provider.tf. Before we go into the other files, I'm actually just going to trigger this environment to deploy because it does take a few minutes to deploy. So rather than we'll sort of sit here and watch lines of code appear, I could be talking whilst that's happening. So just coming back to the key stages, I've already logged into this CLI window. So I've just done an AZ space login, I've entered my credentials, and I'm ready to go essentially. So we'll start with the Terraform Initialize. And what we'll see here is that just downloading a few things. You'll see on the left a folder will appear in a moment whilst it downloads that. Cool. So we're actually now ready to start using Terraform. We have the Terraform binaries downloaded for the relevant providers, and everything is kind of set for our lab to be deployed. What I just want to show you next is one of the really useful features in Terraform. So we can actually run something called Terraform Validate. And what this will actually do is go away and look at my configuration and tell me that the config is valid. Now, this is really useful if you're sort of working on something and you want some confirmation before you deploy it. I'm just going to go to the first TF file here. I'm just going to actually I'm going to add a mistake. So I'm going to make that variable so that it's not valid, and just quickly show you that. So here you go. I've actually made it so that variable doesn't exist because I've put a spelling, taken a character out, and Terraform's actually calling that out to me. So it's saying on line 3, this hasn't been declared. Did I mean Azure-RG1? And if we look at my TF files file here, sorry, not in the TF files, just in the reference here, you'll actually see, yes, I did mean Azure-RG1. So let me just put that back in. I'll save that. And hurrah, the configuration is valid again. So we've run the initialize. What I'm going to run next is just run the plan. Now, what plan is going to do is go off and look at the the relevant provider. So in my case, it will look at the Azure environment. It will see what actually needs to be built here, and then it will come back and tell me a list of items that need to be built. I'd wonder if it was going to stall on me there. It Nice dramatic pause. But what you can see here, I'll just make this a little bit bigger, is essentially this has said there are 27 resources to add, which is great because that's what I'm expecting to see. If I just scroll right back up to the top here, just to show you the whole plan. So what this actually does is shows me all of the resources that Terraform is actually going to produce for me. You know, there's a key vault up there, it's producing a secret here, there's a managed data disk here, you know, even down to things like the tags I've specified, you know, it will actually show me that information. A network interface for the virtual machine, its IP configuration, NSG, you know, public IPs, resource groups, you know, all of that information about what Terraform is going to do is shown right in this plan output. So once we're happy with the plan output, I'll just bring this, oops, just bring this back down. We can actually run Terraform Apply. And what this will do is, excuse me, is again, it will run a Terraform plan. So it'll say, you know, there are 27 things to add. Are you happy with that? And once I confirm yes, it will actually go off and start building that infrastructure. Just move this up to show you again. So as you can see, yeah, 27 to add. Do we want to perform the action? So just something to note here, as much as, you know, I'm sure we'd love to type yes, please, or hooray, go for it. The only answer accepted is yes. Anything else will cancel the apply. So we'll type.
That's very important to know. Thanks.
We'll type yes into there, and obviously, as you can see, this is going off to create things now. So what I'll do is I'll just minimize the terminal, because once that's building the infrastructure, I'm just going to quickly go through what these files are. So the Azure deploy.tf essentially contains all of the resource items I'm asking Terraform to build. So things like resource groups, VNets, and you know, these hopefully look familiar to what I showed you in the registry and the documentation items earlier. It's essentially, you know, just building blocks for an environment that Terraform is building for me. You know, this goes all the way through resource groups, VNets, you know, a VNet peer, an NSG for the lab, associating the NSGs to subnets, the key vault, the creation of the key vault. You know, it creates me a nice random password here. You know, it actually adds that random, the result of random underscore password to the key vault as a secret. And that secret is later on used as part of that virtual machine being built. Now this
yeah, now I also
really...
see how you're using the depends on flag there with the key vault. Thanks.
Exactly. Yeah. So this is a really good example, actually. What I don't want here to happen is I don't want the key vault. Sorry, I don't want the key vault secret to be created prior to the key vault. So within there, there's just a depends on, and all I'm doing there is telling Terraform, you know, please don't attempt to create this key vault secret until that key vault is built. So that's kind of a, you know, sort of a good example of perhaps, you know, how you may need to use things like that. The other thing that's really nice about using the random password feature here is I could deploy this lab 10 times and it would build me 10 infrastructures, and that password would be randomized 10 times. So I could go away and deploy this for 10 different customers, each time knowing the password was different. So there's lots of ways, you know, using things like that, you can build security straight into your code. You know, it's just, it's a small thing to do, but, you know, if for example, you know, you have that as a plain text password, or it's, you know, password 1234 or something like that, and there's some sort of breach, you know, that potentially has an implication for all of the places that code has been deployed. Whereas if you can randomize something like that, you know, straight away you've got an environment that you know is kind of secure and different. You know, the security comes from the fact they're all different out of the box. Public IP here for the VM, so association, so network card associated to the public IP, a data disk for that virtual machine, and then finally the virtual machine itself. And this is another good example where depends on's been used, because the actual admin password for that virtual machine is taken from the key vault. So I'm actually telling Terraform here, please don't build this virtual machine until the key vault has been completed. You know, which is another sort of you know, another useful way you may wish to use depends on. And then finally, just the attachment of that data disk to the virtual machine. So I'm just going to seamlessly switch again. So let's just have a look. Come back to the browser window. Hopefully you're seeing a browser window now. Yeah. So Terraform is actually still building the virtual machine for me, but if I hit refresh now, we should start seeing some resource. So yeah, we can see there's quite a nice list of resources and such like that's actually been created. You know, and what's really nice, if I go into, let's say, something that will have been created already. So let's perhaps pick one of the resource groups here. You know, you can actually see that the tags that I mentioned are applied. You know, they were put in using Terraform. It would be the same on this disk as an example. You know, we've got tags down here. So it just makes life, you know, really easy, really straightforward. If I needed to find, you know, everything that was related to my Cugc Terraform demo, I could click on that, open the tag. You know, I've just got all of that sort of stuff that, you know, all of the best practice around cloud environments can be built in quite easily using Terraform. So another really good example of you know, how powerful it really is. Excellent. So Terraform's actually finished. So bear with me a couple of seconds. I'm just going to do another seamless switch. So you'll see down here, it actually says apply complete, 27 resources added, 0 change, 0 deployed. So that's really nice. When it's green, you know, you can breathe a sigh of relief, because if it's red, it normally means there's something wrong with your configuration or the cloud platform. What I'm going to demonstrate now is just what the impact would be if we made a change to that. So to do that, what I actually need to do is look at our variables. So there's kind of two files that are really important for part of this. Variables.tf actually lists out all of the variables that are required in my code. So everything within Azure Deploy.tf, or any, you know, if this was split across 3 TF files as an example, any variable that needs a response has to be listed in variables.tf. Otherwise, Terraform, when you run the apply, will prompt you to enter that variable. And if you're working in an environment that's got, you know, 100+ variables, having to enter 100 variables and remember them, you might as well go back to, you know, pointing and clicking with a mouse in the portal. You know, it sort of defeats the object. Then my terraform.tf vars file is in essence my answer to the variables.tf file. So within here, what I'm doing is providing that list of answers. Now, what I'm actually going to do is pretend that, you know, Mr. Customer has phoned me up and said, you know, Jake, what are you playing at? You know, I didn't ask for the resource groups to be called this, or, you know, I didn't want it deploying in UK South, or you know, you've got our network range wrong, or something like that. I'm going to make a change to the environment. So I'm actually just going to remove the 2. You know, oops, sorry, Mr. Customer, I accidentally put 2 on the end of the resource group. Now, if you're familiar with Azure, what you'll know is resource groups can't be renamed. Anything within a resource group, if you need to recreate that resource group, would mean removing the resources, destroying and recreating the group, and then recreating those resources. Terraform will handle that for you. So I'll save this file. So in essence, now we've got resource groups that are named CUGC2 in Azure, but in our Terraform, they're called CUGC. So what I'll do is I'll just validate the config again. Make sure that it is valid and accurate. Oops. Sorry, I think I made terminal a bit small there. Yeah, so excellent, the config's valid, so that's really good. What I'll also do now is rerun apply. Now I've been slightly lazy there, because the reality is, if you were running this, you know, in a production environment, you'd probably run plan on its own. But as it runs plan for us, I'm not going to worry too much about that. What I'm hoping to see here is an output that effectively says, wow, you've made a big change, I need to destroy and recreate everything. So we'll let it run through and do that. So you can see here we've got 25 to add, none to change, and 25 to destroy. So what that effectively is telling me, it's got to recreate everything. Now, for the very sort of eagle-eyed and people that were you know, brownie points for the attention you were paying earlier, we're probably thinking, well, earlier it was 27 resources, so what's this guy on about? The reason for that is there are 2 tags that will not be changed as part of this. So sometimes the numbers don't always add up for things like tagging or stuff. You know, we haven't actually changed those tags, so just something to bear in mind. You know, things like you know, recreation of the randomized password. The password would still be the same, even though, you know, some of the resources would get created. So I'll just say yes to this.
So Terraform does understand that if it's just a changeable resource or a property that can be changed for a resource, that it will only apply that change and not like destroy everything and then redeploy based on the Terraform files.
Exactly that. Yeah.
Okay.
Yeah, so for example, if I'd have made a change to, you know, say one of those, the ranges of one of those subnets, it would have just recreated the subnet or changed the range. It wouldn't necessarily involve a recreation of the resource. it's a really interesting point as well, because for example, if you go and deploy this and you've got VMs that you then promote to domain controllers or something like that, you have to be very aware of that. If somebody then says, oh, can you just change all the resource group names, it's like, well actually,
yeah.
no. So this is kind of one of the cautionary things, I think. Whilst Terraform can do a lot of this work for you, there's very very powerful in what it can do, but that does work both ways, in the sense of very powerful for creation, but very powerful for destruction of infrastructure as well.
Yeah, so it would make sense to manually run the Terraform plan first, to see what the changes are, and then figure out what the impact is on your current infrastructure, and then do the apply, right?
Exactly, yeah, and that's certainly what I would what I would advise. There are also ways, it's probably not something for the first few times you use Terraform, but as you get more comfortable, you can actually output the plan of Terraform. You can have that sent to a certain location, or if you're running this in a pipeline, it could do that based on perhaps email it to someone, or you could put a pause in at that point. So actually we have a plan and then it gets paused and someone has to come in and look at it and approve that stage, or something similar.
Yeah, that makes sense.
I'm just conscious of time, so a few things I wanted to cover off. So one of the things that's really interesting about Terraform was the sort of use cases for the Citrix administrator. And obviously, once the Citrix infrastructure is built, a lot of the administration takes place, from within various Citrix consoles and those sorts of things. But I think where Terraform comes in really is around the sort of supporting infrastructure and those sort of pods of deployment. So imagine your requirement is to build out, Citrix deployments in numerous locations, or do it, time and time again to the same standard for a number of different customers. And as an example, that's where Terraform would come in to build out those pods of infrastructure for you. Things like supporting infrastructure, networks, domain controllers, perhaps storage accounts for your software. Perhaps you need a VM to run an application or something like that. Again, that's another place where it would come in for you. Rapid, repeatable deployment. Again, if you have a template that you deploy for your customers, or we deploy this for every department in our business. Again, that's another really good use case. Allows you to integrate with version control systems. So perhaps you're going to take the sort of underlying cloud infrastructure for your Citrix environment, and you're going to put version control around it. So when changes are done, we want that done in GitHub, or we want to do it in Azure DevOps. A really big use case as well is that UAT dev test. So having additional environments to do testing in, giving you the ability to take what's deployed in perhaps your production environment, use Terraform to repeat that somewhere else where you can do, testing easily and take that worry out of it. Things like additional elements, storage for application packages, install media, profiles, you can have standardized templates within Terraform that will do all this for you. And again, infrastructure across multiple cloud platforms. There's no reason why you couldn't have, a provider for AWS and Azure in one file, and have a deployment that links those two and builds out the resources you need. Can make life, sort of very easy from that perspective. This is just a useful diagram to kind of highlight that, but pretty much everything within the Azure, diagram here, you could provision in Terraform, and then just layer the Citrix Cloud layer over the top as an example to provision the desktops and those sorts of services. So very, very quickly, you could start building up layers of resource. This could quite easily be multiple iterations in different locations for prod, for test, all of that sort of stuff. Really does make life easy. Just being, honest and pragmatic as well. If it's your first sort of, getting started with Terraform, the first few years, an infrastructure like this is not going to happen overnight. Build it up in small stages. But once you start getting comfortable with it, you'll see, for example, oh, I can create a key vault. Brilliant, right? I can now create 2 VMs to function as domain controllers. Layer it up like that, and you'll start finding that, you'll know you're walking, because it will feel. You'll see the learning steps, but you'll start running and you won't realize it. Before you know it, you'll be building out lots of infrastructure, using variables, all of those sorts of things, and it becomes, becomes very powerful when you get to that sort of level with it. I'll paste all of these links in the chat as well. There's lots of really good things out there. There's some really good YouTube series. HashiCorp's own Learn section is really good. you know, things like the virtual apps and desktops as code video is really good. I've got some samples for Azure I'll share as well. You know, there's some other tooling as well to help sort of learn and build Terraform. Brainboard's a really good example. I'd also say, you know, particularly for people working in sort of desktop virtualization, if you like Terraform, have a look at Packer. You know, Packer's another way where using predefined templates, you can build out images as well, just to make that really easy. And then a couple of links to some blogs. I've got a small blog series that kind of walks through everything we've been through today, so I'll share that as well. You know, so if you do want to go through it and don't want to listen to my voice, then that's the that's the peaceful version of it.
Well, I still have some questions that I'm pretty sure people would love to get answered. So if you want to hear me talk for a little bit, I will read out some of the questions that we have and see
Sounds really
if
good,
there's still some time. If I'm not rushing you in any way to finish. Oh, look at that. You have the best timing ever, Jake. Thanks. So one of the questions is, when I am creating an infrastructure, is there, for instance, a way to automatically add my own IP address in an NSG to secure the access to the VM via Terraform?
It's funny you say that. Yes, I've actually done that myself. I'm just frantically trying to get to my GitHub in the background, but yes, you can. So Terraform has the ability to pull data from certain areas. So for example, if you were building like a VM and you wanted to pull an admin username, or you wanted to pull an IP address, you know, things like that you can actually pull dynamically in Terraform. It also allows you, working with some of the providers, to pull data from other locations. So the example for an NSG, you can actually use the data resource within Terraform to actually go off to something like, you know, one of the websites that tells you your IP, pull that as a data item, and then enter that data item into an NSG. That's actually, so the lab I've deployed as part of this demo is a slightly cut down version. But in the one I use myself, I actually do that. So that the only person, you know, even though it's a machine that's got a public IP, which I know if there's anybody whose focus is security on the call will be, you know, wincing in terror.
Just ignoring this one, please, people.
Yeah, myself. And for lab environments, and you know, I need a demo up temporarily and quickly, you know, that's a lot more secure than just having it wide open as an example. But
yeah,
yes, there is a way you can do that. I will share a link in the chat when I share a load of other links as well.
Awesome. So there's another question, and I think that relates to the whole, what if I change something in the code? How can I make sure that it doesn't override an existing resource? So the question is, if I wanted to use the code to create a DC, similar as what you did in the example, he said, and I got success and then wanted 3 more. Do I just run the same code 3 times, or will that just override the existing DC that I just created?
So there's kind of 2 answers to that. One of those is if you did 3 separate deployments and changed the variables as an example, then yes, you could do it, but I wouldn't advise it. If it's all part of one deployment, you would be better off either making 3 separate resource blocks, 4 separate resource blocks, sorry, for the original and then the 3 additional ones, and having them as individual resources, particularly for something like a DC, where you might want a DC in one place to have a certain config. You know, those are things you would typically want to manage on an individual basis. The other option you have is to use the count argument, where you can define a resource, so something like a VM, and you can tell Terraform, I want 5 of these, or I want 500 of these, you know, and that certainly has its place for things like subnets, or you know, things like I'm building out a cluster of web servers or something like that. I think, yeah, the honest answer is I would assess that on a resource by resource basis, just depending on what the resource does. For a domain controller, I'd probably want to manage it individually as a, you know, a discrete resource entity. For something like a subnet, or if it was a, you know, 4 or 5 servers all part of a pool doing something, I would probably use count just to generate multiple instances.
Yeah, and I think in this case, what you meant with creating multiple resource blocks is that I need to make sure that the symbolic name of my resource is unique, because that's what it uses to reference if it needs to update an existing resource or if it needs to create an entirely new resource,
Exactly.
right?
Yeah.
Okay. Then I think we answered that question pretty well.
And very quickly, just so I just want to, the demo gods have definitely been on my side today. I just want to show these were all CUGC2 earlier. So the recreation has actually finished now. You know, and all of these resources have since been rebuilt in those new resource groups. So yeah, whenever I next do a demo, I know it's not going to go well because I've used all my luck up today.
Oh, one very important question is there also an option with Terraform to have it, for instance, reverse engineer the code that you need based on existing deployment in, for instance, Azure?
So yes, there is. It's fairly new, that type of functionality, and it's done kind of by sort of additional providers and plugins. There is, I believe it's created by a team within Microsoft actually called Terraform, Azure Terraform, and that actually allows you to take, to take an existing Terraform configuration, have the tooling look at it, and then generate you a configuration based on it. So that's something that's, you know, really, really useful, I think, when you're learning, or if you're trying to bring, you know, existing resources into into management with Terraform. You know, you can point it at a resource group or point it at a specific object and have the configuration generated for you.
That makes sense. And that's a very useful feature to make sure that your code stays compliant with the actual resources that are involved.
Yeah, so you know, for example, if you know, you're asked by a customer to please use Terraform to deploy into this subscription or this resource group, and then you know, you found out that you know, the customer had gone and done a load of extra things themselves, you could actually use, you know, Azure Terraform to bring some of that under management. So you know, you're not then worrying, well, I'm going to run this and it's going to overwrite that or something like that. So yeah, I'm very interested to see where that goes actually, because I think it's something that will become very, very powerful. You know, to be able to bring infrastructure in.
I'm just double checking if there's just one or two more quick questions, because I think we might need to have a separate session or a follow-up session for some of the more advanced questions that are showing up in the Q&A. One of the others was concerning the state file, and I know you didn't focus on that a lot in this webinar, but do you have any best practices for using a state file?
I would say, you know, one of the things, particularly around the state file, is it needs to be treated as something that is A, important, and B, sensitive. You know, a state file is not something you want in a public S3 bucket or something like that. You know, if you're generating, for example, you know, secure strings, or you know, it's recording public IPs, that sort of information. Yeah, it needs to be treated as important. You know, typical sort of best practice would be something like an Azure storage account or an S3 bucket. You know, in Azure, that would typically be, you know, only perhaps a specified user having access, or you know, a service principal that Terraform's running under. Treat it like you would, you know, a sensitive document, you know, that has information you wouldn't want anyone other than perhaps, you know, the people working with Terraform within an IT team getting access to. I'd also say it's really important to, you know, look after that state file in terms of back it up, because if you have a problem with it and you need to roll it back, you know, that's really, you know, it's really going to save you.
That makes sense. Yeah, I noticed that one of the questions in regards to the state file best usage was especially if you want to deploy multiple instances randomly over time. Does that mean you also have to create multiple state files because you're running different deployments? Or if you have a state file in a centralized location, does that mean that it will get updated and keep up with the different deployments that you perform?
So this kind of comes down to the method of working. You know, if you've got one person working on their own, just doing something, obviously that state file is just on their machine. Whereas if you've got multiple teams contributing, you know, to a centralized repo, you still may have a number of different state files. You know, it's not uncommon, for example, to perhaps split the deployments out. And I would look at it as you would perhaps with service accounts or something like that. You don't want, you know, oh, we run all of our pipelines as domain admin, you know, because it just works then. You know, that's not the right answer. So in the same frame of mind, you may have, for example, well, the US team who deploy to the US regions have their own state file. The UK or EMEA team have their own state file. And you may actually take that a step further, you know, based on the deployments. Well, EMEA has prod, dev, test, and they're all separate states. So if there's a problem with one, it doesn't impact on the others. So again, it's a bit like the file splitting question. You know, it's whatever works for you, and I guess, you know, puts the control and sort of you know, the guardrails in that you need to make sure a problem in, you know, deployment 1 doesn't become a problem in deployment 2, as an example.
That makes sense. Yeah, that makes sense. Yeah, I think we handled most of the questions. I'm just trying to see. So what I'm seeing in some of the questions is that people are really trying to grasp the whole idea of using that declarative code to deploy resources in Azure, for instance. But one of the questions is, how would you handle tasks like creating resource locations, machine catalogs, delivery groups, etc. in Citrix DAS?
So as far as I'm aware at the moment, it would just be the supporting infrastructure. I believe there is a provider for Citrix ADC. I'm not aware of a Citrix Cloud one as of yet. That might be that I just haven't come across it. But certainly,
no, let's keep pressuring Citrix to give us that provider.
I mean, that would certainly be something I'd be very interested in. You know, the ability to have all of this defined in files, and you know, think of it from the perspective of, you know, if you can define your machine catalogs and delivery groups and policies and those sorts of stuff as code, then straight away you can take that to different locations. You know, be it on-premises VMware, be it cloud provider. You know, and you've got the Citrix Cloud element built out in code, and you've also got the supporting infrastructure. So yeah, it'd be really good to see that kind of develop, I suppose.
Yeah, that makes sense. Because I think at some level you can also classify that as infrastructure. So it makes sense to have Terraform do that. Because one of the other questions was, so when do you use, for instance, Terraform or a different tool like Ansible to create your deployments or your configurations?
It's a really interesting one. I mean, I've done some work with Ansible, and there is some crossover. Where Terraform tends to have its place is in the build out of the blocks of infrastructure and the sort of the, you know, building out that core element, and then things like you know, Ansible you can layer over the top. You know, so for example, Terraform deploys the VM, Ansible installs applications on it, and so on and so forth. There are other ways around that though. So some of the things I've done previously would be things like getting Terraform to deploy me a VM and then asking it to run a custom script extension in Azure that happens to have a PowerShell script that goes and installs some applications or puts some configuration on it. So there is some config as code you can do in Terraform for things like that, but predominantly it's building blocks of you know, resource rather than configuration on those resources.
Yeah, so it would make more sense if we're talking about OS configuration or application configurations to look for tooling like Ansible, where the real infrastructure layer is definitely something that we can pick up with Terraform.
Absolutely. Yeah, I think it's always one of those. There's loads of ways you can, as with anything in IT, there's loads of ways you can approach stuff. just, you know, sort of what works for one person might be a nightmare for the other, and vice versa.
Yeah, that makes sense. So I think I handled most of the questions. There might be one or two that were so specific that I hoping that you might have some time after the webinar to give them a justified answer. And I did notice that we're running a bit past the hour, so I'm just looking at
it's all good when
Stephanie.
it's
Ah, there
Terraform.
she is.
I'm just going to paste some links into the chat for everyone, but obviously these will go out with a follow-up, but just some useful links.
Yeah, Stephanie will make sure with the follow-up email that those links are also in there for those that might not have enough time to copy everything from the chats. So no stress, people.
No worries. I'll send all those links out in that same email that the recording's in, and I'll send all of these questions over to you, Jake, as well. And if for some reason you feel like writing a follow-up blog, maybe.
Sounds like a good plan to me.
Yeah, that's a request for content for sure. And I'd be happy to help you with that, Jake.
Yeah, sounds really good. Yeah, it'd be really good.
Awesome. Okay. Well, thanks everyone. Thanks, Jake. I really appreciate you coming out to be a presenter this time. It's nice to have you on as a presenter.
No, my pleasure. Yeah, really good to be here, and thanks for having me. And yeah, thanks, Esther, as well.
Yeah, thank you, Esther. I'm glad you could be with us today because you understand all of those questions much better than I would.
Yeah, I'll make sure to tag the questions that Jake already answered while I bombarded him with all the questions. So you know which one are still open to be answered, Jake. And then,
Brilliant.
yeah,
Thank
thanks
you.
for having me, and thanks for being so very clear and enthusiastic about Terraform and explaining how we can create even faster infrastructures and more consistent infrastructures with Terraform. Thanks, Jake.
Thank you. Cheers. It's been good.
All right. Thanks, everyone. I hope you all have a great rest of your day, and we'll see you at another CGC event soon. Bye.
Cheers.